Fine. Let's start. 15 minutes gone now.
Recording in progress.
Today, I'm going to concentrate on generating engineering drawings, 2D drawings, we call it usually, from your 3D models. And remember, you can still start your 2D drawings, except finalizing them with dimensions and other annotations while you're still modeling, right? While you're still modeling. So that is possible, so that you can immediately start, at least practicing if you are not complete. Models are anyway just 3D models. Anybody can't see any difference over there. But engineering drawing, you cannot just escape like that. So please keep this one in mind and watch carefully, listen carefully. And if you have any doubts, any questions, please ask. But this is the standard, right? So you can't just violate these things. So let me first give you some examples so that when you refer this later, you can see that your design should also be something close to this. There are certain components, I have not given the details, but anyway you can understand. So first I will try to discuss about how you generate drawings, and then important thing is geometric dimensions and tolerances. Maybe might find it difficult to understand both of them at once, but I'm not going to go even deep into the dimensions and the tolerances part. And also, this is another one that is actually I think I click on the wrong thing. I go to the first slide. And then the animations as well, but I thought maybe I will take animation a little later. Once you finish your models and everything, then we can start creating the learning the animation. So that I might take one more session. I discussed with Dr. Lihil, should be okay. But more important thing is you create your drawings well and then finish your design. Just a general comment from what I mean, have noticed from the last your presentations, and within my group, you still have to improve a lot, right? I mean, if you produce your models and drawings like this, because we have the technology today, right? So if you produce this one, for example, in an interview or someone else, they might, misjudge you, your skills and everything. So please put some effort, learn, and then deliver it up to the acceptable level. Don't just try to think of completing the thing, right? Completing the thing. All right. So before I continue with this one, I will show you some examples, right? Just captured from various places. So this is one example. And you can see, if you can interpret the things that you can see here, that means you can, exactly what to include in your drawings as well. Now, for example, I'll just highlight some of the things. Here you can see we have a special thing here, right? That also need to be included because this shaft is turned maybe between centers of a center lathe. So that particular thing is to provision for the centers, right? So that you have to give the details of that one. In your drawing, you have to include that one. If it is not, just maybe holding in the vise or something like this, or maybe a chuck or something, then of course you don't need. Remember the manufacturing processes we talked about. So we have to give all the details because the machine operators will simply follow your instructions, simply follow your instructions. And then of course you can see the bearings are mounted. You can see there's a collar, right? And this particular gear wheel, I think I discussed this one in the last week. It's an integral part because the diameter is so small. So if you separate the shaft from the gear wheel, maybe it will fail. It's become too thin. So in that case, you make the shaft and the gear wheel as a one integral unit. And still you can see there are some steps here to support the bearing, to support the bearing. You know, when someone insert the bearing or mount this bearing into the shaft, it's very difficult for you to get the exact position unless you have something like this. The reason is here the bearing and the shaft, the fit is kind of an interference fit. Right? If it is a loose fit, probably you can think of that you can start, but that should not be like a floating thing. Right? So that someone is inserting the bearing should know that beyond this point, the bearing will not move. And of course, if you enlarge this area, some of the diagrams is even showing that one, the bearing corner radius at this particular point, and then the shaft, the step, there is a corner radius. So the shaft corner radius should be smaller than the bearing corner radius. Otherwise, the bearing radius will be in touch. So you won't be able to insert fully onto the shaft. And at the same time, you can see on this side, right, the bearing outer ring is fixed, tightened using the end cap. Using the end cap. You can see even in the bottom one, it is also the same thing. It is also the same thing. Now in this particular case, you can see both sides are fixed. You can see over here and also you can see here. Means nothing is free to move. Nothing is free to move. Otherwise, what happened is, you know, I mean, the whole thing, maybe with gear wheels and everything, will start moving back and forth. That's not acceptable. That's not acceptable. But there are variations. Now, for example, if you need bit of allowance for temperature increase and then the thermal expansion to take place without stressing the shafts and the gear wheels, then only one side can be keep it a little clearance so that it can move back and forth. It can move back and forth with the bearing and the shaft, everything, because the fit between the housing and the bearing outer ring is loose, right? So that it allows the whole unit to move, especially in case of the thermal expansions and other things. But you have to make sure that it is fixed on the other side. There are cases, of course, we keep both ends float, but it depends actually, depending on the cases. Now, you need to think at what speed you are, what kind of or amount of heat is going to generate. It's not possible to calculate everything in a project like this, but still, when you do a real work, you need to think of all these things. Think of all these things, and also you can see here there is a small, you see a packing light thing, the black color one, right? What is the reason for that? You see now this particular end cap is going to contact one side that displays the housing and displays the bearing outer ring. If you think of the dimensional tolerances, right? If you think of the dimensional tolerances, if this height is smaller than the bearing, the width or the thickness of the bearing, then maybe this side will be in contact first. That side you have a clearance. And if the other way around means that the depth of the end cap is greater than the what you call the bearing width, then this end will contact the housing, will be tightened the maximum possible, but still there will be a clearance. Because you can't reach all these things because everything, remember, will end up with certain tolerances. Bearing will have a certain tolerances, end cap will have certain tolerances. So you will never be able to get all these things equal. So you have to think of all the possibilities. So that is why we have put a small of gas cut over there or maybe a seal over there. The other one is the oil can squeeze through that particular thing, right? Oil can squeeze through that particular place. And what is missing here? What is missing here? You can see this is the shaft supposed to go out of the end cap or the housing. You see over there. So in that case, you need to have a seal over here so that the oil or whatever the liquid inside will not squeeze out. Right? So that provision has to be there. And also the seal should be able to fix it. along the shaft and housing as well, because nobody should be able to assemble these components there as they wish. This is the main requirement of design. Right? Someone else will be assembled. Right? So if there are allowances, I mean, you keep it like floating, let it decide by the who is going to assemble the thing. That's not going to work. The design is just simply insert. If it doesn't fix, and then of it, I mean, you go into the other direction. But if everything goes in, everything is the same, looks like the same, then you're confused. Then you're confused. You might, assemble in a wrong sequence, wrong way of like that. Right? And also in the second gear, you can see there is a hub. Width of the gear wheel, that is maybe this much. And more than that, you have the hub of the gear wheel, which is more than that. Sometimes you can have it only one side, otherwise you can have it onto the other side. Right? And things that you have to notice here, the shafts are steps, bearings and other things are already fixed onto the housing. All these things are required. And also maybe a small gasket here, or maybe a packing here, in order to accommodate the variations in dimension, as well as to have a positive ceiling between the housing and this one. And there is another one you can see over there. In that case also, you can see this is a double row, I mean the angular contact ball bearing, you can see here. So depending on the bearing, the mounting arrangements can be different. Certain bearings like angular contact bearings and other things need preloading of bearings. You are not just drawing. Don't just draw. Start producing items or even modeling items. You need to have a purpose of this one. Why am I doing this? What should I do? If I do it like this, will it serve my purpose? I mean, this whole project is to, I mean, learn and understand all these steps. Otherwise, anybody can, produce all these items and then put them together, but they will not function. They will not function. So I have given you these examples to see how these variations can be put into your drawing as well. Put into your drawing as well. So we have to consider them but seriously, how the bearings are mounted, how the end caps are mounted, and how the bush or whatever it is, and also some standards like how to produce gear wheels and like this. Right? You can see this is now this bearing over here on this side is slightly different from the bearing on the other side. Can anybody see the difference? What is it? Yes, what is it? Is there a difference? The mounting arrangement, you see here in this side, like as I told you earlier, in this first part, housing over here, I the sill from both sides. But here you can say at this place, you don't have anything from internal things, right? And here you have that one internally. I hope I can make it a bit thicker. You see that you have it over here, but you don't have it here, right? But it is fixed from the other end. It is fixed from the other end. And also you can see there is a small plate like thing here. Can you see over here on this particular place? So when you place snap rings and other things like this, make sure those things will either touch the outer ring or the inner ring, but not both. But not both. Right? So this is almost fixed at from this side. And this is looks like a separate unit, for example. Housing may be a different one, and the bearing and whole thing can be assembled as a separate unit and then put them here. For example, so for example, this particular part. looks like they're separately assembled. You can study this one. You can open it and then you can study it carefully. Right? So these things are, applied based on the requirements, and then even things like that. For example, this is the way to produce a technical drawing or a production drawing of a spur gear wheel. Right? At the top of this one, you have one profile is drawn. Actually, this is also not necessary. This is also not necessary. Now, this is in case of manual drawing. Because why we are following such a standard like this? Suppose your gear wheel has 50 odd teeth. Then how do I do all 50 teeth? It's rather waste of time. It's rather waste of time. To avoid that one, we just use these notations. This is how you produce that one in manual drawings. But the problem today is that because you are generating in using a CAD package, the CAD package, as far as I know, are still not capable of producing gear wheels like that one. Because we are the one who knows that one is a gear wheel, right? For the software, it could be anything. It's just a shape. We are the one only who's going to identify this one as a gear wheel. But for the machine, it may be a different thing. So that we have to indicate this is a gear wheel, produce the gear wheel of the standard drawings like this. That might be still difficult. But anyway, on the other hand, because you are generating through a computer software, it won't take that much time. It won't take that much time, right? So maybe you can produce it like this. Imagine if you're going to draw all these things manually, right? The pattern command, the array command, all these things are not available in the manual drawing board. So you have to do it manually, right? So maybe there are workarounds. I'll show you, right? Even in the CAD packages, you can get something similar to figure 1. But everything is not fully automatic. Sometimes you have to modify something. And at the bottom right hand side, you have your title blocks, and above that one you have the gear specifications. You see the dimensions are not given usually, right? The dimensions are not given in the drawing itself. It's given on separately on a table. The module, the number of teeth, the pitch diameter, tooth height, and all these things, all this is given. But there again something wrong here. You can see. Can anybody highlight what is wrong with this particular, the information box for the gear specification box? Can someone figure out quickly what is wrong there? Looking at the gear specifications, module 4.5, it has to be a standard one, right? And number of teeth 22, okay. And then the pitch diameter 99 millimeters is okay. And then we have the tooth height. How much is that? Look at the number of decimal places in millimeters, right? It's even beyond that we can go in today's, even the technology is advanced, we can't go into that much of accuracy. So it means the person who has prepared this particular drawing has put this one without rounding off. If you do this one as your final drawing in an industrial design, which is completely wrong, even if you add additional zeros, say for example 10.5 is not the same as 10.50 or maybe 10.500. They are all different. Maybe numerically the value is still 10.5, but for manufacturing there's a huge difference. First one you manufacture to the first decimal place accuracy, so it could be 5.1, 5.2, 5, I mean 0.52, 53, 54 like this. Second one, when you say 50, then you cannot have 5.23 like this. Then it should be 0.5010203 like this, right? So there you can see even the head diameter. What is this one? Okay, that's also you can see up to many decimal places. That should not be the case. Please note that one, right? Please note that one. So that first place and the second place which are not correct. That is maybe here and also maybe here. Right? They're not correct. And even on the other side, it is the same. Actually, it is the same drawing that I have split onto two. And then in addition to that one, you can see some, so the machining marks are over here, given here, right? That you need to machine, and then also some symbol and then a value is also given. That also you need to understand what that is. In machining, you have to give the maybe machining type, machining direction, the tolerances, maybe the surface finish, or whatever. Sometimes you say, do not machine this particular surface. All this information should be included in your, together with your production drawings. The machine operator need to follow that one. If he can't understand, then he should to contact some superior and then clarify what does this particular symbol means. So it says you need to finish to a certain finish. Why? Because maybe you're going to insert this one into a shaft. Rotating at very high speed. Imagine if you have a clearance, what will happen? What will happen? Right? And look at the second drawing on the right hand side. The dimensions for the keyway is given. Look at the height, the depth of the keyway, to the vertical side. Some used to define this dimension. I'll just show this one. Maybe only this particular dimension somewhere here, right? I can't this one up to this point. Maybe from this point to that point, which is difficult to measure, right? At the end of the machining, how can I measure that one? But we give this one that can be measured easily. That can be measured easily, but it is given only to what? 1 point accuracy, whereas this one is given to the second place accuracy, and its tolerance is also given. So what does that mean? The key type is tightening from location, positioning from both sides, not from up and down, top and bottom. So your design calculations and everything you have performed according to that type of what do you call the alignment. You have to give that indication. You have to give that indication. Otherwise, the machine operator might machine it on his own way. Right? So that is not allowed in designing. This is now you are communicating all your design requirement, design specifications, limitations, everything in a technical drawing like thing. Right? So that all these things have to be all of that part. Oh, my animation's a bit late. Doesn't matter. Maybe I will clear the previous one. Now you can see a gear wheel with some hub, means material removed. This is, I think, available in the Gupta book, I hope. Right? Sometimes you need to do calculations. Sometimes there are standards that you can follow, right? Based on the load rating and other things. Now this is to what? Reduce the weight. Oils, this kind of thing you can easily cast. There are cast gears as well. Huge gear wheels sometimes are cast, right? So that reduce the weight, it can be done easily, very easily. And look at the one on the right hand side. There are many symbols given. What do they mean? So for example, if you take that in middle, there's a diameter of 126 or something. And immediately to the right of that one, you have something like 130 H10 or something. And also 20 diameter 8 or something. And that is a capital H and this is a simple H. Right? And some machining symbols are there, and also the surface roughness is also given. And in addition to that one, there are some other information which appear in the boxes. So what do they mean? What do they mean? And also you can see in the middle, together with that 20 diameter part, and at the other end, the bottom corner, you have letter A. Letter A. So what does that mean? Now dimensions are, of course, these are called the nominal dimensions. You design the part to a nominal dimensions, 10 millimeters, 15 millimeters, or even 10.2 millimeters. These are what you call the nominal dimensions. So far, what you have been using is the nominal dimensions. But when you manufacture, you will never be able to produce that one to the same accuracy. Right? You're thinking of not one part, not two parts, but many parts. This is what you call the machining tolerances. Machining tolerances. It depends on the machining operation. Right? It depends on the machining operation. So, for example, here you